Greetings, my fellow chemistry enthusiasts. This is Montfort ChemPath here, bringing you the final part of this series, the mole concept. In today's video, we'll be focusing on more mole calculations divided into two sections: percentage composition by mass and using Avogadro's law. So, when we speak about percentage composition by mass, consider the compound sodium bicarbonate, and then we want to find the percentage of sodium in sodium bicarbonate. What we basically want to find is the mass of sodium in sodium bicarbonate expressed as a percentage. So by definition, percentage composition by mass of an element in a compound is the fraction of the compound's total mass that comes from the element expressed as a percentage. Here we have the formula: percentage by mass equals mass of an element in 1 mole of a compound divided by the molar mass of that compound by 100. Let's consider this question. Calculate the percentage by mass of nitrogen in ammonium sulfate. In order to answer questions like this, firstly we must find the molar mass of nitrogen in ammonium sulfate. And finding the molar mass of a compound is basically the sum of all the area values present in that compound. So the molar mass of ammonium sulfate will equal to nitrogen, which is 14 grams per mole, plus 4 times 1 grams per mole and this will be multiplied by 2 because this 2 here governs everything in this bracket. We have sulfur, which is 32 grams per mole, plus oxygen 16 grams per mole times 4. And we must have a total sum that equals 132 grams per mole. Now that we have found the overall mass of ammonia sulfate, then we could go on to find how many moles are present, how many moles of the nitrogen atoms are present in ammonia sulfate. So looking at the formula, there's 2 moles of nitrogen atoms present, and the area value of nitrogen is 14. Therefore, the mass of nitrogen present in ammonium sulfate will be 14 times 2, 28. So now we have found that 28 grams of the nitrogen atoms are present in ammonium sulfate. Now we could find that mass in percentage by using the formula: percentage of mass is going to equal to the 28 over the 132 times 100, since percentage is out of 100, and then your final answer is going to be 21.2%. So there is 21.2% of nitrogen present in ammonium sulfate. So that is how we answer questions like these. In this question, we read: a compound contains 40% of carbon, 6.7% hydrogen, and 53.3% oxygen. Its molar mass is 108 grams per mole. Find its molecular formula. in order to find the molecular formula of something, we must find the empirical formula if the empirical formula is not given. And when we speak of empirical formula and molecular formula, the empirical formula is a compound in its simplest mole ratio. And the molecular formula is the formula of a compound with its exact number of atoms present in that compound. So let's use the pizza example. Let's say we're making pizza and we're using 2 slices of cheese to 4 slices of pepperoni. The ratio to make that pizza is going to be 2 to 4. Right? And to find the empirical formula of this we basically find it in its simplest form. And to break down the ratio, it will basically be 1 to 2. So that's gonna be your empirical formula, which we use in EF. Right? And your molecular formula is basically the multiple of that empirical formula. So that, and the molecular formula is more greater and is more bigger. So now if we want bigger size a bigger size pizza, right? Let's say if we use 3 slices of cheese to 6 pieces of pepperoni. So now your molecular formula of this pizza will be 3 to 6. Right? And if we break it down, we should get back 1 to 2 as the empirical formula. So the molecular formula is just the multiple of the empirical formula. So now that we understand what the difference between empirical and molecular formula, we can now go ahead and answer this question. And how we approach this question, we first make an assumption that this sample contains exactly 100 grams. Right? We make this assumption mathematically so that the calculation will become easier. Right? So we first must find the empirical formula, and how we find the empirical formula is by finding the number of moles of of each of the individual elements present in this unknown sample. So we have carbon, right? We have hydrogen, and we also have oxygen. And we're using our basic mole formula, which is mass divided by molar mass, to find the number of moles of each of these individual elements. So carbon, which is 40 grams, divided by 12 grams per mole. Right, that's 3.33 moles. For hydrogen, it is 6.7 grams, divided by 1, and that will be 6.7 moles. For oxygen, it is 53.3 divided by 16, and your answer will be 3.33 as well. So now that we have the number of moles of each of the individual atoms, we could then take the smallest moles out of the tree and divide it throughout. Because remember, we want to find the smallest mole ratio possible. Alright, so it will make sense if we take the smallest number of moles and divide it throughout, and that will be 3.33. So if we divide this 3 out, that will be 1, C will be 1, H is going to equal to that's 2, and oxygen is going to equal to 1. So now we find the empirical formula, which is CH2O. But that's just the empirical formula. Now that we have found the empirical formula, in order to find the molecular formula, we basically find the molar mass of the empirical formula and we divide it by the molar mass of the unknown sample, which was given as 180. So the molar mass of CH2O is 12 grams per mole, and that will equal to 30 grams per mole. So now we have found that we take the 180, therefore the 180 grams per mole divided by the 30 will give us 6 as the moles, right? And then we have 6, we find the moles, or the multiple of which we're going to multiply the empirical formula by. So 6 by 1, that will be C6. 6 by 2, that is 12, and 6 by 1 is 6. So it's C6H12O6, commonly known as glucose, right? So if I should write this clearly, it's the 6 multiplied by CH2O will give this. All right, good. So using Avogadro's law, let's say, imagine we have 2 balloons. Right, one balloon has O2 gas and the other has carbon dioxide. Right, both balloons are at the same temperature, it has the same pressure and the same volume. What Avogadro's law says is equal volume of gases at the same temperature and pressure contains equal number of volumes or moles. If both balloons are at the same size, why would one have more particles than the other? The gas particles in the balloon, they are spread far apart. They expand to fill the container, so the volume depends on the number of particles and not really the type of gas. So the same volume equals the same number of particles, even if the gases are different. So that is why it complements Avogadro's law. So in the first example, calculate the mass of methane in 480 centimeters of methane gas at RTP. The key thing to note is the condition in which this gas is operating under, which is RTP. And gases on the RTP operate at 24 dm cube. Right? And because it is in dm cube, there's a conversion that needs to take place, because we have the volume of gas, which is in centimeter cube. So to convert this, right, the conversion is basically dividing the 480 by 1000. So 480 divided by 1000 will equal to 0.480 dm cube. Right? Then after we make our conversion, we use the formula, which is to find the mass is mass will equal to the number. Sorry, I take that back. We have to find the moles, right, of the gas. So we have the right, we have the molar volume, which is 0.480 divided by 24. That will equal to 0.020 moles. And then now we are finding the number of moles. We can find the mass by taking the number of moles and multiplying it by the molar mass of methane. So 0.020 moles multiplied by 16, and your answer will be 0.32 grams of methane. Alright, so the next example, calculate the volume of 3.08 of carbon dioxide at STP. Their area values are given. So how do we go about answering questions like this? Firstly, we must find the number of moles of the carbon dioxide. Alright, we are given a mass, and we can find the number of moles by finding the molar mass of carbon dioxide and then dividing the two. So the molar mass of carbon dioxide will equal to 12 grams per mole plus and that will give you 4 grams per mole. So now that we have found the molar mass of carbon dioxide, we can now find the number of moles by dividing the mass by the molar mass. The number of moles of CO2 will equal to 3.08 grams divided by 4 grams per mole, and your answer should become 0.070 moles. So now that we have found the moles, we could calculate the volume, right, by using the formula volume equal the number of moles times the molar volume, which is in dm cube at STP, and that will be 22.4 dm cube. So 0.070 times 22.4 dm cube, your final answer will be 1.57 dm cube. So that brings us to the end of this video. Right, a few exam tips. Make sure you divide the moles using the smallest number of moles. Make sure when you're carrying out the calculations involving gas volumes that you check if the conditions are RTP or STP, because the volume of 1 mole of a gas varies with temperature. It also varies with pressure. Alright, so make sure that you know how to convert from CM into DM and DM into CM. If you want to convert CM to DM, we divide by 1,000. And if you want to do the reverse, we multiply by 1,000. And if you find yourself struggling with chemistry, I tutor chemistry online. Right, my WhatsApp number is on the flyer, so you could contact me. Right, or if you know anyone that needs the extra help or the extra push in mastering chemistry, you could hit me up. So I hope you find this video useful. All right, leave a like, leave a comment, subscribe to see more videos where I break down complex topics simple to understand. Thanks for watching. Goodbye.